Hi everyone. Following our discussion on performance and accuracy, today we are shifting our focus to two equally critical pillars for any generative AI application: cost and scalability. It's not enough for an LLM to perform well. It also needs to be financially sustainable and capable of growing seamlessly with your business needs. This deep dive will explore how we can build Gen AI solutions that are both cost effective and robust. Let's get started. Let's start with cost, which I like to call the hidden iceberg of Gen AI. What you see on the surface, the direct costs, is often just a fraction of the total expense. Direct costs are typically what first come to mind. If you are using managed services, it's your API usage, paying per token or per call to providers like OpenAI or Cloud. If you are self-hosting, it's the compute resources, the expensive GPUs and CPUs needed for both training and inference. And of course, data storage for your training datasets, fine-tuning data, and the models themselves. But the real challenge, and where many projects underestimate, lies in the indirect costs, the below the surface part of the iceberg. Fine-tuning a model requires significant data preparation, compute, and specialized expert time. Development and integration costs involve substantial engineering hours to build the application around the LLM and integrate it into existing systems. Then there's ongoing maintenance and monitoring, keeping models updated, ensuring they perform as expected, and troubleshooting issues. Security and compliance are paramount, especially in global companies requiring investment to ensure data privacy and regulatory adherence. And don't forget the human in the loop. For many critical applications, human review of AI outputs is essential, adding to operational costs. The key takeaway here is to always consider the total cost of ownership, not just the initial API fees, to truly understand the financial implications of your Gen AI solution. Next, let's talk about scalability, the ability of your system to handle a growing amount of work or an increasing number of users without a drop in performance. For generative AI, where adoption can explode overnight, scalability isn't just a nice to have, it's a fundamental requirement. So why does it matter so much? Firstly, for user experience. If your application can't keep up with demand, users will face slow responses, errors, or even downtime, leading to immense frustration and abandonment. Second, for business continuity. A scalable system ensures your Gen AI application remains available and reliable, supporting critical operations without interruption. And finally, for cost efficiency. Scaling efficiently means you only pay for the resources you need when you need them, avoiding costly over-provisioning. However, scaling Gen AI applications comes with its own set of key challenges. Resource provisioning is complex. Dynamically allocating expensive GPUs or CPUs as demand fluctuates is a fine art. Model serving itself is challenging due to the sheer size of these models, requiring efficient techniques to load them quickly and serve requests. And for conversational AI, state management, maintaining context across user interactions adds another layer of complexity. We typically think of two types of scaling: vertical scaling, which means making a single instance more powerful, like upgrading to a bigger GPU, and horizontal scaling, which involves adding more instances of the same component, like deploying more servers to handle the load. Both have their place in a robust Gen AI architecture. So how do we tackle these challenges? Here are some effective optimization strategies for both cost and scalability. First, smart model selection is paramount. As we discussed, smaller, specialized models, perhaps fine-tuned open source options, can often be more cost-effective and efficient than massive generalists for niche tasks. Consider using a tiered approach, a smaller, faster model for simple queries and only escalate to a larger, more expensive model for complex, nuanced requests. Next, inference optimization techniques are crucial. Quantization is a powerful method where you reduce the precision of the model's weights and activations, for example, from 32-bit floating point to 8-bit integers. This significantly reduces memory footprint and speeds up inference with often minimal impact on accuracy. Techniques like pruning and distillation can further reduce model size and complexity. Pruning removes unnecessary weights or neurons from a large language model to make it smaller and faster. The idea is that many parameters contribute very little to predictions, so cutting them out reduces compute and memory with minimal loss in accuracy. Distillation trains a smaller student model to mimic a larger teacher model. The big model generates soft labels, examples, and reasoning traces, and the student learns to reproduce the same outputs. This compresses knowledge into a compact model that's cheaper to run while keeping most of the capability. And leveraging efficient inference frameworks like NVIDIA's TensorRT or ONNX runtime can provide substantial speedups. Caching and batching are also your best friends. Caching involves storing responses to frequently asked questions or common prompts so you don't have to regenerate them every time, saving compute and latency. Batching allows you to process multiple user requests simultaneously, making much more efficient use of your GPU resources than processing them one by one. For deployment, embracing cloud-native architectures is key. Serverless functions are excellent for bursty, unpredictable workloads as you only pay for the compute time you actually use. Autoscaling groups can automatically adjust your compute resources up or down based on real-time demand, ensuring you always have enough capacity without overspending. Finally, don't forget monitoring and cost management. Implement robust logging and metrics to understand exactly how your resources are being consumed. Utilize cloud provider cost management tools to track spending, identify inefficiencies, and optimize your budget. Proactive monitoring is essential to keep both cost and performance in check. To quickly summarize our deep dive into cost and scalability, here is a sustainability checklist for your Gen AI applications. First, always understand the total cost of ownership, looking beyond just the visible API or compute fees. Second, prioritize efficiency by considering smaller, optimized models for your specific tasks. Third, design for scale from day one, thinking about how your application will handle growth. Fourth, optimize inference using techniques like quantization, pruning, and batching to get the most out of your resources. And finally, monitor and manage your usage and costs continuously to ensure long-term sustainability. By keeping these points in mind, you will be well equipped to build generative AI applications that are not only powerful and accurate but also financially viable and ready to scale. If you find this content useful, please like, share, comment and subscribe for similar content in the future. See you in another video. Until then, elevate